Hi everyone, it's Mr. Roy. Let's do a quick tutorial on graphing two variable data. Okay, with this we're kind of taking a look at our pendulum lab and we want to know how to graph our data for this lab. First, let's have a look at some of the data I've displayed here. So I've put it into some tables using Excel and I've kind of got my data ready to go. Right now though, it's looking pretty messy. So let's clean this up a little bit. The first thing I want to do is I want to put like a grid around these things. So I'm going to click this little grid button here and I'm going to say all borders. I want to have some nice borders around my data. That's going to make it a little easier to see and a little easier to parse, and this can improve things quite a bit. I can just take these and just copy and paste them directly into PowerPoint or Word or any of those things as well. I'd also like to bold my titles here to make them look a little bit better. You'll notice in these titles I have the things that are in them. I have units if they have units. And I've also stated whether it's the independent variable, which is the thing I'm changing on purpose, or the dependent variable, which is the thing I'm measuring. In this case, we're measuring the period for every group. Now, I kind of want to have those titles look like the headings for these columns look a little nicer. So let's actually change that to black, and let's change my text to white. That'll kind of make it stand out a little better, and we'll have it show up a little better. So it's bolded and stands out nicely. Okay, now I've got some really nice data tables. I could just take these, copy them, and directly paste them into any document I was working with. It is bothering me a little bit that these two are showing up without the same number of decimal places. So I can actually force it to show a certain number of decimal places. If I right click on it and I go to Format Cells, I'm going to say number is the one I want to choose. So not general, I'm going to make sure it's a number, and I'm going to say how many decimal places. I would like you to do 2 decimal places for all of them. So this is kind of nice. If I tell it to do that, it'll force everything to display as 2 decimal places, and now it looks a little bit nicer. Okay, let's actually do some graphing. Now first, we see an example that is one variable data. I have some different things here, like I'm moving in a different medium, a pendulum in air, water, canola oil, or jello, and then I have my average of those. But the thing is, um, there's no number for air. Air is just air. There's no number for water. Water is just water. I could look up the density of each of those, and then I would have a number for them, but I haven't done that. So this is one variable data. You'll see under the period, that's my one variable that has a number attached to it. So the way I'm changing the medium, I'm not changing a number, I'm changing something qualitative. So I've only got one number associated with each data point. So we call this one variable data. Let's graph our one variable data. I'll include the average in there as well. I'm going to go insert for a graph. Now I could do a scatter plot, and I could say, let's do a scatter plot, and it looks like this. But this is one variable data, so it has no meaning when you put it in a scatter plot like this, because only one axis should have numbers on it. As you can see, this doesn't make any sense. So I'm going to get rid of that. That is a nonsensical table. Instead, I'm going to insert a bar graph. This will do one variable data for me. There we are. So on the one side, I have my period. That's my dependent variable. So I want to put it in the Y column. So it's on the right-hand side when I do it in my table of values. And that looks pretty good. I can change my chart title. I can add some new titles. If I click this little plus button up here, I can add some axis titles, and I can put some axis titles in there. I can just click in there and write in what the different things are. Now, I just made up this data. In truth, these numbers are actually very similar. It's surprising that the period doesn't change when you put it in a different medium. It slows down a lot faster. The amplitude goes down. It swings less, but the actual period to go from one side to the other doesn't actually change, which is kind of fascinating. Okay, so that's my one variable data. I could clean this chart up, improve the title, improve the axes titles, and then I'm ready to go. I'm going to get rid of that one though, and we're going to look at two variable data because this is really what we're after. Two variable data, we notice each data point is going to have two numbers associated with it. So the height of the stand I've changed on purpose, and the period I've measured. So my independent variable I changed on purpose, my dependent variable I measure. Now you'll notice I have units at the top as well. I don't want to put those in my column because then the thing won't know what to do with it. It won't realize it's a number. Now I think we can all agree that changing the height of the stand probably isn't going to change the period because it's not actually changing the pendulum itself. It's just changing how far off the ground it is. So I've chosen this one because this is one that I think we can all agree probably isn't going to make a difference to the period. But I've included data that makes it look like it is, just so you'll know what I'm talking about. But this is not real data. This is just data I made up. So I'm going to grab everything here, but I'm not going to include my two titles. Okay. I'm going to say insert, and I'm going to try and make a graph. Now, if I tried to make a bar graph, you'll notice this is a nonsensical graph. I've tried to do two variable data in a one variable format, like a bar graph. So this doesn't mean anything, right? So I'm going to get rid of this. I'm instead going to go insert, and then I'm going to go to my charts here where it has a scatter plot. And I'm going to say which one. I want the one that doesn't have any lines on it, just that one in the upper left. So I'll insert that. Now, a lot of times what will happen with your chart is that your dependent variable won't start at 0, or maybe your independent variable won't start at 0. For me, I'm lucky. Both of these start at 0, which is great. If they didn't start at 0, it could make my graph look very deceptive. I could have a very narrow window, and I want it to start at 0. So I'm actually going to double click this if it didn't start at 0. And I'm actually going to make a change so you can see what that would look like if I started at, say, 1.5. My graph would look like this. It's still the same data, but it gives the impression by looking at it that the increase is much bigger than it actually is. We got to be careful of that. So if you find that this is not starting at 0, we want it to. So double click on the axis when this pops up. I'm going to say, what's my minimum? My minimum is going to be 0, and I'll reset it like that. Same thing on the x-axis, my independent variable. I can double click on there, and I see, oh, it's already set at 0, right? If it wasn't, say it was set at 20, my graph would look like that. Not what I want, so I'll set it starting at 0, and that looks good. Usually the default is fine, but it might not be. You can also change the number of significant digits displayed or the number of decimal places. It's actually, decimal places is the only way you can change it. But if I double click on here, I'm going to be able to change the number displayed. So I'll click on this little like table one here, and I'll go number. And you can see it says general. I want to change it from general to number. And I want to have it go to 1 decimal place. So I'm going to change this to a 1, and you'll see that all of my values now go to 1 decimal place on this axis, which is nice, which is kind of what I want to see. And I already have 2 decimal places here, so that looks good. Okay, so my thing is nicely aligned. I'm going to change my titles now and make sure that they are very representative. So I want to fully explain what is going on here. So I'm going to say the effect of changing, and I'm changing here the height of stand height. And I don't have to say the height of the stand. I can just say stand height. I can leave out those joining words. Stand height, the effect of changing stand height on period. And period of a pendulum. Okay, so I've got a nice title that really clearly explains everything that's going on in the graph, right? I want someone to be able to read it, and by reading that title, know what they're seeing. So I've talked about both my variables there. Okay, let's add in some axis titles. So I'm going to say add in some axis titles. Remember, I click the plus button in the upper right-hand corner, and then I go over to the side and I choose axis titles. Let's have a look at that again. I'm going to click my chart, I'll click my plus button, and I'll go axis titles. Boom, here they are. Okay, so my first one, I'm going to, get back here, axis title. I'm going to click on it, I'm going to delete everything that's in there, and I'm going to describe what this is. So this is my independent variable, it's my height of stand. So I'm going to say height of stand, and then I'm going to say it's my independent variable, and then I'm going to put the units I put in centimeters. Over here, same deal. I'm going to get rid of it. I'm going to say period of pendulum, and I'm going to say that's my dependent variable, which is always on that axis, and I'm measuring it in seconds. Okay, so I got some nice axes that mention my variables and my time. That's perfect. Let's do, the next part is going to be my line of best fit. Now, if you are used to doing this on like a paper thing with a ruler and a pencil, this is not that different, but the computer is going to do it much more perfectly for us and give us a lot more options. So I'm going to click the plus button. I'm going to go all the way down here to trend line, but I'm not going to click trend line. I'm actually going to go here and I'm going to click the arrow and say more options. And it's going to open up this box on the side. If it doesn't open it the right one, just click this little chart here for trend line options. Okay. Now I'm going to go right down to the bottom and I'm going to choose a couple of options here. First, I'm going to display my equation on the chart and I'm going to display my R squared value on the chart. Now my R squared value is going to tell me how close, in this case it's doing a line of best fit, how close these dots are to being in a perfect line. If they're in a perfect line, that will be 1.0. It'll be a value of 1. All the way down, you can get close to a 0 if the pattern is completely perfectly random and there's no way they line up at all. Now in this case, it's close to being a line. It's my R squared value is 0.9878. Okay, now you don't really need to know all the details of this. If you take data management, data management course, you'll learn more about this. So there's a couple math courses where you'll dig into this. For now, we just want to know that it represents how close it is to matching that pattern. So it's very close to being a straight line. 0.9878 is close to 1, close to a straight line. But let's try a couple of other ones. Other options I want you to consider is it could be a polynomial. Now we're going to keep the order 2. That means a quadratic, like y equals x squared, right? So a parabola, a quadratic like we did in math class. Now this one, my R squared value is 0.9965. That's actually much closer to 1. Well, a little bit closer to 1. So that one's actually a better fit, and it gives me an equation in quadratic form here. So that's closer to being a representation of what's going on. Now, why do I want an equation from something like this? It allows me to make predictions outside of my data set, right? What if my stand was 10 centimeters? What if it was 1 centimeter? What if it was 4 kilometers? This allows me to make some predictions outside of the actual data that I took, which is really useful in math and science. So I say, okay, that one looks pretty good. The last one I'm going to suggest I could try is a power, and that's 0.9835. So that one looks like it's not as good of a fit. So in this case, for my made up data, which I made up, it's not real data, a quadratic, which is a polynomial of order 2, is going to be the best fit. So that's the one I'm going to choose. Between linear, polynomial order 2, and power, I'll choose the best of those. So there we go. I'm going to display it on the chart just like I needed to. I'm going to move this over just a little bit so it's easier to see. I could even make it bigger if I'm feeling like the text is too small. I can just grab it and I can say make that text a little bit bigger. I could bold it if I want it to be a little clearer to see on the chart. Now to me, everything looks good. I've got nice labels, I've got nice axes, everything's starting at 0. I've got a title at the top that explains what it is. Last thing I'm going to show you is we can actually put this in a different spot. If you don't like this covering up your data, you can right click on it and I just say move the chart. And I'm going to move the chart to a new sheet. And I say okay, and now the chart is in its own spot. Now you see if I'm over here, I can see my data. I'm clicking down on the bottom left. I can also click to see my chart. Here's my chart. Now you may find that when it does this, the data labels are too small and things are too spread out, in which case you can double click on this and grab it, and you could change the size of this as well if you wanted to, or bold it, or whatever you think looks good. You can also change the size of your axes by double clicking on them and changing the size there. But in this case, I think I actually liked it better when my chart was in its place where it was before. So I'm going to tell it to move it back. I'm going to say move my chart as an object in the sheet. There it is again. And when I want to paste this somewhere, all I have to do is click on kind of the background area of the chart, right click, say copy, and now this is ready to paste into Excel or into PowerPoint or into a Word document or whatever. You're using presentation software for this, so that is where you want to paste it, is into your presentation software. Okay, I hope that helps you make a graph. Let me say one more thing when looking at the graph. We're going to look at trends here, right? And you're going to have to analyze the trends. I think things may go up or down a little bit, but what you want to look at and analyze is this a big difference? In this case, I found that my period was going from what was my lowest one here? It was going from 1.6 all the way up to 2.3. That's a significant difference, right? That's a lot. So to me, I'm seeing in my fake made up data that yes, the effect of the height of the stand is having a big effect on the period. In reality, we know that probably not the case. Now, if you're finding that your original data is, as we found in class, was a period of 1.2, then you have one that's 1.3 and one that's 1.2 and another one that's 1.1, another one that's 1.3, another one that's 1.2, and it's kind of making a straight line, that's probably just noise in your data. That's probably just like random little things or little tiny experimental errors that can't be avoided. It's probably an indication that, that the thing you were studying doesn't have an effect on period. If you're going to see an effect, it will be noticeable. So if you're seeing that it's changing by the tiniest bit, but not really much, that probably just means it's noise in your data. If you're noticing a big change like I did here, that probably means the thing you changed does affect the period of a pendulum significantly. Okay, I hope that helps. Good luck in your graphing.